Here we'll discuss exponential graphs and their domain and range. First, let's look on the left side and look to our 2 raised to the x graph. Notice it's a different form than anything we've done previously, because previously we've had x raised to a number. In this graph, we have a number raised to x. If you look at the shape of this graph, you may be able to see that there is an invisible wall that the function can't cross. I'm going to outline that invisible wall in orange to make it easier to see. If we follow the graph toward the left side, it seems like it's going to keep going down, but before it goes down toward negative infinity, it turns and starts running to the left instead. This invisible wall that seems to stop the graph from going down any further is called an asymptote. Now, this asymptote is going to limit the range, but not the domain, because that asymptote, in this case, is going to affect the y values, but not the x values. Therefore, we can treat this asymptote like it's a minimum. However, when we treat it like a minimum, it's important to note that the graph will never cross that wall, and it will never even reach that wall. It will just get really close to the wall. With that in mind, let's think about our domain and our range. For our domain, we look only at our x values. As we said, we do have a left arrow, and we know a left arrow denotes negative infinity when we are talking about domain. We also have a diagonal arrow on the right, but since it is pointing to the right, we can consider that positive infinity with regard to the domain. So since we have a left and right arrow, our domain will be negative infinity to positive infinity. However, for our range, we do have a minimum, and that minimum is right on the axis, and so that minimum is 0. However, if we follow the graph upward, we can see we still have an up arrow, and because we have an up arrow with regard to range, that up arrow represents positive infinity. When we write our range, we'll have a parentheses around the infinity and a parentheses around the 0. We're not using a square bracket for 0 because the graph never actually reaches 0. Now if we evaluate f at 0, let's find where x is equal to 0, place a dot at that position, and try to read the y. Notice that this point is halfway between 0 and 2, and the number that's halfway between 0 and 2 is 1. Therefore, we'll say f at 0 is 1. On my graph on the right, notice that I do have a decimal number raised to the x. However, this will behave very similarly to my previous graph. My domain still has a left arrow and a right arrow. The left arrow, even though it's diagonal, we know represents negative infinity with regard to domain, and the right arrow represents positive infinity. Therefore, our domain will be negative infinity to positive infinity, and this will always be the case for exponential functions. However, for our range, let's try to locate where the wall would be. We may be able to see on the right side that the function begins leveling off fairly quickly toward the right, and we're going to draw in the orange line to denote that. We can see that this function will have a minimum, and that minimum is halfway between 0 and 2. This means our minimum will be equal to 1. Again, we call this an asymptote. So since we have an asymptote at 1, that will be our minimum. And our maximum, since we still have an up arrow on the left side of the graph, will have a positive infinity for our highest part of the range. Therefore, for our range, we always read bottom to top. So our lowest number will be 1, our highest will be positive infinity. Again, use parentheses because we will never actually reach that 1. Once again, if we try to find f at 0, let's put a dot where x equals 0, and we can read that the y value is 2. We'll place a 2 for our answer for f at 0. So even though the domain is the same for any exponential function, the range will change based on where our asymptote is.